around. But in more recent years, actually, IPv6 has gone down. So internet security, the challenge, because, you know, if security fails, then it's a really good reason and an imperative to be working together with each other to the thing. The only one, because the internet is full of NOGs, but it's also full of certs and IXPs, and it's possible to run all of these sort of components of a good, healthy internet ecosystem according to the best current. Share that knowledge with you. So again, I'd like to congratulate everyone who's brought SANOG back to Pakistan again 3 years later, and I'd like to suggest, as Rupesh said, that it's probably time for Pakistan to have its own NOG, so that you can meet more regularly and continue this important work of collaborating together. And I really hope that some of you at least will be inspired enough by today and by this week to give that some serious thought, because if you do, there'll be plenty of people and organisations around the region that will be ready to help, and that includes APNIC, where we'll be happy to make a contribution to costs to help things get started, because as I said at the outset, we really do believe in NOGs, and in the same way that we've always believed in the internet and these things together. APNIC started back in 1993, and as I said, our clear purpose was the development of the internet in the Asia, just next month in Melbourne. And we've also supported training and conferences and events like NOGs, SANOG and PACNOG and BTNOG and many others. And we use these to deliver a lot of training, because we know that, you know, aside from the internetworking, aside from the collaboration, the mutual support, we know that the hard expertise that you can get from good topical training is. Last year in 2019, APNIC held 67 face-to-face trainings around the region with something like 2,000 trainees. We've launched Academy, one of the new top-level domains, apnic.academy, and that's had more than 5,000 registrations so far, and that's for self-paced online learning where you can receive certificates for some of the courses that you go through there. And we've attended at the training workshop in SANOG-35. So all credit to SANOG also for putting together such a fantastic training program this week, and I really hope that everyone here is staying on for some of that training, because yeah, as I've said, network operators are the core of our membership, and we see NOGs as the best way to reach and interact with you. So come and talk to any of the APNIC folks who are here. If you've got any questions about membership or resource requests, about IP address transfers, for instance, or anything else, just let us know, and feel free to approach any of us as friends. Now, a few words about IPv4. The current situation and status of IPv4 is kind of on everyone's lips these days. You know for sure that the internet has been built on IPv4. In fact, v4 was adopted in 1983. In fact, it's been around for a very long time. But with only 4 billion addresses available in the entire IPv4 pool, it was never intended actually to support the internet. Designed IPv4 just never expected the kind of success that we've seen. So today, I think most people know that IPv4 is effectively 512 addresses, which is only available once to every organisation. And that's being made available, and it's being rationed in order to help you to connect to the IPv4 internet, but it's not enough to build an IPv4 network. So you can buy IPv4 addresses on the open market. That exists due to policy changes that we made a few years ago. But unless you can afford to buy a lot of addresses, and they're fairly expensive, you really just cannot build a network these days on v4 alone. So the fact is, we all have got to prepare for IPv6. We've got to learn about it and plan for it, and at some point get some of at the moment. Think about more than the billion users who are using it at the moment. We're back? We're back? Not yet. So that was a big bang, but that's for thinking about 1 billion users on IP, about 25% on average. And there's some countries that are much bigger. So the US now is over 50%, India is over 60%. And so it's happening. It changed fairly quickly, and I really do it in panic, greenfield, and as I said, APNIC will to do more of that with you of readiness to do some major with just a few points about and some reminders for events and activity support and the participating activities. And there are some important things coming up. So at this coming Apricot conference, which represents our annual meeting of APNIC for the coming 2-year term, meeting in Melbourne, but that's quite a long way away. So you can also vote on. Chain, you'll be notified by email, and also you can find information online on My APNIC about that. But I really do call the policy development. We register and we coordinate things like transfers of addresses. These things are all done according to policies or rules that we have to follow them on the community. But in fact, we follow the rules. Those rules to be examined, running, and you can, in particular, the community here and related to IP address academic conferences and something routing security. You can participate in that here, and that's in Dhaka in Bangladesh in September. Said, great place to learn in person. That would be fantastic. We have some fellowship funding available for some people who might need some support with their travels, and you can apply for that, and you'll be able to see information about that coming a little bit closer to the event. The APNIC survey, which I mentioned, is something that happens every 2 years. And so this year will be a survey year. And with the conference in Dhaka in September, we'll be launching the survey for 2020. And that's an opportunity that APNIC actually really relies on for members. Also, what is it that APNIC can do to help you in the work that you're doing? Because we take that advice and we use it to really plan the activities and priorities of APNIC. And so, again, that's another way in which I would really ask you, please, Nick, and I'm very glad to have been able to come to Karachi. It's really wonderful to be here and to finally see friends from Pakistan in their own country. I mean, people like Aftab and Naveed, who are international personalities, but they come from here. So it's fantastic to see them at home, and it's fantastic to see the work that's being done by the community here. APNIC will continue to work in Pakistan, with Pakistan, however we can, and you can tell us how we can help you with the community and with members. And maybe one day, soon, I hope, with a Pakistan NOG, which we would love to see happen. Because we all want to keep building the internet in the best way that we can. You've got some very exciting challenges and times ahead, and I really do, on behalf of APNIC, I really do, and we do look forward to working with all of you. So thank you for your attention this morning, and see you again soon. Thanks.
Thank you, Paul, for your keynote about IPv6 runout and future of internet. From APNIC perspective, we've heard a lot of things from NOG if it's established soon. As he's suggested, the focus right now is on internet security and IPv6. And fortunately, we have a workshop, 4 days workshop in those 2 tracks in this SANOG-35 as well. So I think this is as per the demand of the APNIC members. All of seats available, so if anybody wants to be part of the workshop, which starts on Wednesday, you can still join. Also, I think Paul mentioned about the NOG, CERT, and IXPs. also about SIG and surveys that APNIC is doing. So thank you, Paul, for your continued support to SANOG on behalf of APNIC and the community in South Asia. So thank you very much to APNIC as well as Paul Wilson. Thank you. Next, I would like to request Mr. Maruf Sahani, COO CyberNet, to deliver his keynote about journey of ISPs and Internet in Pakistan. Maruf.
Thank you, Rupesh, for coming all the way to Karachi and sharing this session. Thank you, Honorable Chief Guest, Junaid Imam Saab. And thank you, Paul, for explaining this, what is happening around IP version 4 and version 6. So echo back what Junaid Saab said and echo back to Paul and everyone. We tried to took initiative on PKNOG long time ago. We're still trying to bring PKNOG back. We really needed support from international community to bring PKNOG back in the country. I can feel it that PKNOG is really desired and required in the country. We started a few years back. Unfortunately, in the country, these mobile operators came from voice background, not from the internet background. So we tried to convince them that these forums like SANOG and NOG are very, very important to contribute, make bigger changes in the country. So we're trying, but I personally feel that the government, like ministry, and the international community, they really need to talk to the important people who have a more influence in the country, whom we can convince that this is very, very important to take initiative like NOG. We started this PKIX a few years back. I'm part of this PKIX initiative too. We tried to bring PKIX in the country. We started from Islamabad and bring it back to Karachi and then Lahore also. So hopefully this 3 IX will be up and running in this year. However, there's an urgent need to get this PKIX registered and recognized by the international community. Therefore, CDNs and the international partner can come in and join. So this is what I wanted to echo back before I discuss about my presentation. So a lot of colleagues here are from technology background. Most of the people I can feel, a lot of my colleagues, they work for the ISP industry, especially they spinned off from CyberNet, joined the international community like Aftab, Haris, and a lot of our ex-senior colleagues are here. So they have witnessed how this ISP journey has been done in the last 15, 20 years. Maybe few of our young leaders, maybe they want to know, so we can just have a small recap. Right. So a lot of people talk about that, why don't you talk about yourself? What happened? What sort of accident happened with you? So sometimes I feel it's too much to talk about yourself, but sometimes my team says that you should tell this on the forum so people can understand that what sort of accident happens in the life. So my family, my parents wanted to make me a doctor. They pushed me when I passed out the matriculation, and they said that you have to become a good doctor because of our hometown, we don't have doctors. But I found when I was in first year, I found that I'm very good in maths. So I listened to myself, and I had a big contradiction with my parents. Then I said that I want to go and opt for the engineering field. So I listened and decided to go into engineering field. So after passing out 2 years per engineering part, I got the admission in engineering. When I got the admission in engineering the first year, I personally felt that there's no challenging stuff in the engineering. It's very pretty simple to pass out the engineering field. So I was personally inspired by a lot of government people. They used to inspire us while we were studying that, why don't you come into civil services? So the 2 years, I'm more focused on the civil services. Then after 2 years, I came into 30 engineering. There was an internet revolution in the country. So as a student, bigger challenge than technology, but I personally felt that technology is a bigger challenge, and it's going to become a bigger challenge. So in this way, accidentally, I came into technology field, and I started this journey while I was a student. I saw this, I witnessed this, even when I passed on the intermediate, I saw this. So I have almost 20 years experience having seen these industries changing from analog to digital, initially from moving from writing digital over analog. Now we are fully digitized in the country. So I'm the board member of PKIX and PKNOG. I'm trying to bring it back in the country. My life vision, I wish I can get retired before I turn to 50. So I have seen a lot of disruption in the technology. So I personally feel that there is an urgency for our senior leaders to come up and work on the ethics, work on our values and education. So that's my mission, hopefully. Hopefully before I get retired, before 50, I will start working on this. So everybody knows this journey started from 9 kbps in the country. We witnessed, and now we are witnessing more than 500 megabits. A lot of operators have tested even 1 gigabits, but practically we can get 500 megabits. So this is the whole journey in the country's happened. So this internet started this with the funding project by Usenet in the country, and they started this commercial email services. Not the commercial, but this funded global funding we got for 3 cities. So we started from this email services. At that time, we as a student were witnessing that now this traditional mailing system is changing, and it's moving to the digitized based email services. So this is what we witnessed in 1990s, early 1993. Then this first dial-up services in the country happened around 1993. I remember one of the ISPs and one of the renowned telecom engineer, Mr. Nasir Khan Ghazi, he took a lot of initiative earlier. I don't know what is he doing nowadays, but he has a lot of contribution earlier in the industry. So we started this 64 kbps backbone in 93, and we started watching this first time browsing and started commercial. So one of the ISPs started commercial services called Digicom. So one of our Epic colleague was asking that when submarine cable landed in the country. So this is the complete journey of the country. Started from 1992 and 93, the first dial-up services. Then we have, in 1995, we have first Digicom launched this services through the SCPC link and offering a commercial email services. Then we have ParkNet, they launched this ISP services. Then we formed the PTA. We felt that the government needed some sort of regulation needed, so PTA was formed in 1996. Then a lot of other ISPs from ComSat to CyberNet, where I'm working, we started in 1997. Also, first submarine cable, I think Ronnie asked me the questions, when the submarine first cable came into the country. So it was early 2000 when CMEV3 we got. It was the first buy landed through the PTCL incumbent operator. Then there were a lot of disruption in the submarine industry in 2006 when we got a second upstream provider. Then there was a lot of disruption in the telecom industry. We launched broadband services in the country, the first broadband services in 2001 by an Islamabad-based company called Micronet. Then the same company with a different brand called Nayatel, They launched this FTTH services in the country first in 2006. After 2006, the different fixed line wireless operator came into, through the WiMAX investment, we got the 3.5 gigahertz band in the country. So we have fixed line wireless, like few companies like Cybernet and Wateen and other companies, Whitetribe and QB. Unfortunately, you guys know that what happened with the fixed line after coming up with the mobile operators. So in 2009, Cybernet planned to lay the FTTH infrastructure in the country because we felt that we have to build a highway in the country for fiber backbone. So we started laying for enterprise customer in 2009. Till now, we are laying the fiber in the country for the access and metro. In 2014, Cybernet launched this fiber to the home services for a brand called Storm Fiber. So we have touched the masses in houses and commercial buildings. And we have launched in 8 cities and few cities more to go. Also, there are other brands called Optics and other Transworld Home and other FTTH players are coming up. Also, in 2014, we got 5 telcos. They got the license from moving from 3G to 4G. So they got license thanks to the government and ministry. They enabled us, though we were bit late in 2014, but we got the 3G, 4G license for most 4 or 5 mobile operators. And then this fixed line operator tried to come up and compete with mobile operator. So in 2016, also Whitetribe tried to launch the 4.5G, but still it's pretty challenging because there's a lot of fixed line limitation in the spectrum. Then in 2018, we got this Pak-China OFC connected. So Pakistan got connected with China through the optical fiber lane route. So with this hope that there will be a lot of transit traffic. It's not yet happening, but it's going to happen very soon. Then in 2019, Pakistan became, I think, in South Asian countries, it was the first country who got this 5G test and trial by 2 companies in the country. So this mobile broadband has taken over in the country. They have a lot of internet penetration in the country. So we started in 1993 on the voice services, 2G or 1G initially started from AMS, the 2 companies, Instaphone and Parktail. And then they moved the technology from AMS to the GSM. And after this 2G started by Mobilink, we moved to 2.5G in 2005. I think in 2005, we have this GPRS services in the country. So this 3G, 4G services really have changed a lot in the country. Most of the mobile operator offer now is 3G, 4G services in the country, right? So I know, Haris, I have no time, so I have just quickly wrap it up, right? So we are already short of time. So this 5G services in the country, I think this is going to have a bigger ecosystem in the learning has to come up to enable this 5G ecosystem. So the Pakistan has 230 million population. So I think there's a lot of attraction for 5G ecosystem. So to recap, what the country have submarine cables. So we have 6 submarine cable currently running in the countries having 60 terabit capacity. And we have around 2 terabit capacity we are using currently at the moment. Now there's a good news for the country, Paul and everyone. So there's a good news for the country that Cybernet is bringing a 3rd submarine cable with the carrier-neutral data center in the country. So this data center and then the submarine cable will be from Pakistan to Marseille. We will have around 89 millisecond, Paul, it's 89 millisecond latency from Karachi to Marseille. And this Cybernet will bring in a couple of months, hopefully end of this year or initial of the 2021, we will land this cable. So in a nutshell, we started as a country in 1990, starting from voice services and then moved to the broadband services. Pakistan have currently, as I mentioned earlier, 60 terabit capacity, but we are still with the 2 terabits, so it's a long way to go. A lot of penetration has to happen in 3G, 4G, and fixed line broadband. So, as I mentioned earlier, this total consumption is around 2 terabits. So today, in the country, we have smartphones, we have peer-to-peer applications, we have enterprise application, but this is going to change a lot in future for the 4G, 5G, when the 5G ecosystem comes in, because a lot of smart machines are coming up, a lot of AI is happening, more than our imagination. A lot of IoT is happening thanks to the government taking a lot of initiative on IoT. I'm listening a lot every day. So thanks a lot. There's a lot of virtual realities happening in the country outside, so there are a lot of initiative coming up. So where we as a country placed, we have around 90% geographical coverage through the mobile services, and we have around 163 million users, subscribers on the mobile. So there's a lot of attraction to the different businesses from the globally to the country, because we are almost covered through the mobile services in the country. The cost of the telcos in the countries are lowest. The ARPU is lowest in the world, I think. So let's see the small snapshot. We have over 163 million cellular subscribers, as I mentioned earlier, and 73 million broadband users. Out of 73 million, we have around 2 to 3 million, less than 2 to 3 million broadband fixed line customers, 34% in mobile space, total 75 million. So it's a long way to go, especially on this side, on this fixed line side. There's a lot of to be done on the fiber to the home side or FTTH side to building the access infrastructure. So a long way to go for the country to enable every house and every office with the fiber to the home infrastructure. And also this will enable mobile broadband through the backhaul services. So we really needed to build the fiber infrastructure in the country and fiber highway in the country. So this is small snapshot for the mobile penetration in the country. Earlier we had a 4 mobile operator, 5 mobile operator, now merged to 4. So why is this merged to Jazz? So you can understand that's how much penetration Jazz have and other mobile operator have. So this is broadband subscriber by penetration around, we started from 2014 till now is 34 million. This is, you can see this broadband is catching up in mobile space, and it's not yet catching up in the fixed line. So we really need to work hard to enable each house and each offices with the fixed line. So this is a fixed line space. So the government structure of MOITT, Janessa is sitting here, so we have a lot of we have a PTA handling the regulatory body, handling the telecom regulation. We have a national IT board, and we have a universal fund. So universal fund help us to put the infrastructure in suburb areas where we don't have the infrastructure. So that's why we are able to have a 90% infrastructure in the country. A lot of support from universal fund. We have NTC, the government organization of telecom services, enabling government institution for the telecom services. We have SCO handling the north part of the country and connecting China with the country with a lot of security issues. So it's a special telecom company handling this. We have Ignite, Janessa is CEO and handling, we earlier mentioned about that. We have a PSCV, they're handling the software part, so exporting, handling, managing certification, doing everything. We have a telecom foundation for trainings, and then we have a virtual university starting from diploma to PhD programs in the country. So what we need, so in my opinion, like earlier mentioned, that we really understand the importance of forums like SANOG, and we really understand the importance of local NOCs in the country. So we really need to push our local NOC, and then we need to get help from the SANOG and other forums to enable our country and developing this culture. We need to have a private-public partnership. We need to enable this culture. We desperately need an advanced curriculum to enable the universities and academia, because I personally feel that there's a lot of gap between the academia and the industry. So we need more involvement. We need a lot of revamp the tax. I urge Junaid Saab to study on the tax system, because the central bank already acknowledged that highly taxed telecom industry is highly taxed. So we really need to work out and revamp the tax regime. We need to work with the application provider. Especially, we need to reform this right-of-way policies. That's more than 50 institutions are handling this right-of-way in a different way. So we must have a uniform policy. Therefore, we can lay the fiber optic infrastructure in the cities. We need more free zones. We need to promote PKIX or different internet exchanges, and we need to invite our CDN or the international companies, international CDN provider to host with the local IX. So as I said earlier, that State Bank also realized that this is a heavily taxed, especially the telecom and ICT industry. So taxation is very high in the country. We must have some income tax holidays on the venture capitalists. We must bring this tax from 34% on the broadband, 19.5% sales tax, and 12.5% advance tax. We must work and at least bring it to 5%. Therefore, we can invest more on the telecom infrastructure. So we need even interbank exchange rate for the IT industry. We need an easy import-export. Junaid Saab, this telecom industry is still not as an industry. When we import the equipment in the country, it's still not recognized as an industry, though it has a lot of contribution in the country. So we need to really announce it as an industry. Therefore, this can enable other industries. So I just wanted to, I know we are late, so I just have 2 minutes, 3 minutes to talk about a lot of disruption happening in the world. Around 500 million Twitter messages are being sent every day. There are 210 billion emails are sent. With this 207 billion emails, we have around 7 billion Google search. So there's a huge amount of data coming up. Around 105 million Tinder people are clicking every day, like or dislike. So there's a lot of data exploitation happening in the country. So I personally have witnessed in various countries, I witnessed. So I have just put this picture just to open up my mind and everybody's mind that even we go to the restaurant, we go to the house, we go everywhere, everybody is on the mobile phone. So we are losing our emotions, our intimacy, our love, our relationship. So even if we are eating on the restaurants, we are only on the mobile all the time. So while eating, both gentlemen, I spoke to them in China last 2 weeks back. I was there. So they were just eating and doing something on the phone. And I was on the next table, I was sitting there, and I was just talking to my friend, and then I spoke to them that you guys have come to here just to enjoy the time. So this generation is changing very rapidly, very fastly. So it's very important for all of us, especially the government, especially the SANOG and other communities. They really need to look upon what sort of values we are losing, what sort of culture we are losing, what sort of beliefs we are losing. We can't resist this technological explosion and change, but we really need to work on fast pace to study that what sort of ethics we need to bring in, which can protect our culture, which can protect our values, which can protect our human relationship. Mothers have no intimacy with their children I can feel it that all the children, they want to sit on the mobile all the time, so they lost their emotional attachment with the relations. So I personally feel that there's a lot has happened in last 75 years, and in next 5 to 10 years, this is a lot going to happen, whatever happened last 75 years. So we all need to really, as an even Pakistani community and a South Asian community, because we were given this technology in our hand, we did not invent this technology, so we could not understand the impact of this technology on our personal life. So it's very important for all of us to look, study, and see what the impact technology is impacting on our personal life, on our emotional life, on our values, on our culture. So we need to protect that. Thank you very much.
Thank you. Thank you, Morav Sahab. So before we end for the tea break, I would like to request Mr. Paul Wilson to come up on the stage, and Mr. Harish also, if he can come on the stage, to give away some of the token of appreciation. To start with, I would like to request member of IT, Mr. Junaid Imam Sahab, to come up front and accept our small token of appreciation from Paul. Junaid Sahab, I'd like to request you to stay on the stage for a while so that you can distribute some of the other token of appreciation. Next, I would like to request Junaid Sahab to give out the token of appreciation to Mr. Paul Wilson. I would also like to request Mr. Maruf Sahani to come up on the stage and accept a token of appreciation from Junaid Saab. Yeah, Harish, if you
Rupesh to put his laptop, because next I'm going to announce the name of Rupesh, sir. Why don't you say, I'm so sorry. So Rupesh, and I would like to briefly touch upon, because Rupesh is the SANOG chair, and he has been instrumental in arranging this event, which is in our opinion a great turnout, and people will be enjoying a lot in terms of understanding the engineering side of things. So I would like to request Mr. Junaid Imam to give the token of appreciation to Mr. Rupesh. I would request another personality, Dr. Shahab Imam. He has been very, very instrumental in arranging a few of the things here, which you don't know. Some of the NOCs and everything comes from his side. He is a pro bono advisor to a lot of ministry work. Dr. Shahab Imam, thank you very much, sir. All right. So we have a very techno comms team, right? So music and everything. Next, I will request Mr. Aftab Siddiqui to come on stage and receive his token. Aftab has been very, very instrumental. He works for ISOC, and he sits on a lot of boards here and there, but he has been very, very instrumental in getting SANOG in Pakistan. The doctor behind a lot of presentation program and filtering out a lot of presentation. We got 50 of them, but he chaired and he reviewed everything. Dr. Philip Smith, I've known for quite some time, and he's been really, really instrumental in bringing the knowledge sharing and exposure to Pakistan and rest of the community. Dr. Philip Smith. I would now request dearest friend Gaurav. I would just want to touch a brief history. I remember in 2005 when I first met Gaurav, and from that point onwards, I think all the discussion of IX and root server replication started, and we deployed the first F-root instance in Pakistan. And Gaurav is the founding member of SANOG. Right now, he works with AWS. And amazing person, and he has helped Pakistan in IPv6 a lot. Thank you very much, Gaurav. That's it.
Everyone, I would like to end this session for now. I'd like to request you all to go for a quick refreshment, coffee refreshment outside. Since we are a little late, running a little late, I would like to request you to cut short the coffee break. Maybe we can use 10 to 15 minutes at the max. If needed, you can take a coffee and then come inside and enjoy your coffee while we start the next session. Let's start the next session in the next 15 minutes, shall we? So please enjoy the refreshment outside. By the way, also for the next session speakers, I would request you to come up front and meet me so that we can prepare for the next session. The speakers for the next session, if you can come up.
member, and I will be moderating this technical session. In this technical session, we have some honorable speakers lined up to present topics on data transmission, DDoS mitigation, and IP4 update. So allow me to introduce our first speaker, Mr. Atif Wasi, who is associated with Arista Networks as Sales Engineering Manager. In this talk, Mr. Atif will share his vision for how the 400G and 800G transitions will first manifest in data center, then in short-haul interconnects, and then extend to 1,000 kilometer and beyond, all based on next-generation digital coherent optical technology. So please welcome Mr. Atif.
Good afternoon, everybody. It's my first time in presenting in SANOG over here. So a brief introduction. Atif Wasi, I work at Arista Networks as a sales engineering manager. I'll be here for the rest of the week over here, so if you have any questions, feel free to grab me and ask me anything you have. My detailed contact information is here as well. To start up with, I think it's a relevant topic in the sense that if we look at the transformation of technology, where everything is moving towards, right? Today, where we are is introduction of 400 gig in the networking space over here. And as we have all seen, the fastest way to go is to go really fast, in the sense that if you look at where we were in 2000, where we were at speeds of 1 gig, now we are talking about 400 gig. And in order to be able to support all the IoT devices, 5G, and broadband accesses, right? So we need to keep advancing on the technology scale over here. So 400 gig is the way to go fast, and then after that, we're going to clearly see the 800 gig introduction over here. So in this chart, I mean, you'll see the trends where things are and how things are moving towards. Is not too long ago, in 2015, 2016 timeframe, we were at 40 gig, and 100 gig was just being introduced. And if you look at the projections, which is coming out in the next couple of years, the 400 gig is shipping today as we speak. So 2020, we have already started shipping 400 gig. And by, I would say, in the next 3 to 5 years, it's going to be the predominant technology to be deployed, not only in data centers, but also in the long haul and the short haul fiber optic networks over here. And then if you look at the revenue forecast, right? I mean, it's all driven by the cloud customers, right? The price per port and the densities that is being driven in the environment that you'll see today is all driven by the cloud. And as the volume, and as you'll see that the volume increases in shipments of these products, the price per port is going to come down. And you have seen that in the case of 100 gig introduction, and it's going to be soon to be 400 gig. Now, 100 gig was pretty interesting in the sense that if you look at the adoption of 100 gig, it really went through the roof between 2016 to 2017, right? That's when the 100 gig really was adopted widely, and the biggest reason is, again, the volumes came in, and with the volumes, the prices came to a point where it was able to readily deploy in the data centers, and then it permeated into different parts of the networking world as well. Now, if you look at the 400 gig, right, the projection in the next couple of years, you'll see that by 2022, we are going to do the thousands of 400 gig ports being deployed. Again, data centers are the first ones to start deploying 400 gig, and then it's going to become long haul and short haul, and in the core routing space and towards the edge as well. So soon, I would say in the next couple of years, you'll see 400 gig being actively deployed in the backbone to be able to support all the technology advancement that's happening in the industry. So now if you look at the crossover point, this chart is pretty much a couple of years old. So I would say we are a year or so running behind. The crossover point for 400 gig over here showing up as 2020. We are in 2020. There have been some challenges with regards to optics in the 400 gig space. So that's the reason why there's a slight delay. I would say we're pretty much running a year behind. So by next year, this time, or probably middle of 2021, is you'll see 400 gig in volume deployments and shipment as well. Now, I mean, this slide is pretty interesting. What used to happen, if you look in the past, is new technologies that were being introduced, there was a premium attached to it, right? So when we went from 1 gig to 10 gig, the 10 gig price was not any lower than 1 gig, right? I mean, even though the densities came up, but the price per gig was still pretty high. Now, with the data centers and the cloud customers and the service providers out there, the message is pretty clear, right? They're not going to deploy a new technology and pay a premium for it. So the price has to be at least be more, per gig basis, has to be more cost effective than what we have previously being deployed over here. So the key thing again is as the new technology is being deployed, the premium goes away. So the question is, how do you do that, right? How can companies deploy and build systems and be able to sell cost effectively and be able to support all that is required from the network infrastructure? The answer to that is merchant silicon. And I'm not sure how many people in this room are familiar with merchant silicon, but when I say merchant silicon, what it means is that the ASIC that is in the networking device, built by the non-traditional companies, monolithic companies, for the likes of Cisco and Juniper. So, for example, Broadcom, right? So Broadcom is a company that makes merchant silicon along with Intel, and companies like Arista and others out there, they use their silicon and build the systems on top of it. So what used to happen in the past is that the merchant silicon was lagging behind as compared to the traditional routing vendor companies, but it has caught up, right? So the number one thing is today, if you look at the merchant silicon, it can be a full-fledged router, right? So able to support millions of routes in the hardware. So the common misconception around merchant silicon not able to support the features is no longer there. It's being actively deployed by a lot of large customers out there in the world. And if you look at the growth of merchant silicon, again, it matches to the feature sets that's available, right, across in the merchant silicon world. So in 2014, if you look at the percentage of merchant versus custom or proprietary chips, merchant is again fast catching up in 2016. And as we speak 2020, if you look at the latest numbers, it's even going beyond that. And if you look at the merchant growth path, right, it's on a different trajectory versus custom silicon. And that's the advantage of companies focused on building a solution, just focus on the hardware ASIC. If you go back in time, I don't know how many people of you remember Sun Microsystems. So Sun Microsystems had their own ASIC. Intel started coming up with x86. And if you look at what happened in the next 10 years, Intel was able to easily take over Sun. And then Sun no longer became a viable business, and then they were bought out by Oracle. So in the merchant silicon, we're seeing the same trend over here. Prior to the merchant silicon being introduced, the price per port along with the densities were growing really, really slowly. Right? Moore's law wasn't being effectively implemented in the networking space. It was available in the x86, but in the networking space, it was lagging behind. And when merchant silicon came in, they were able to support the densities and be able to support the scale that is required today in the space that we're talking about here. And again, the reason we're able to do that is the technology on the silicon itself. If you look at this chart over here, in 2010, right, where the CPU was at 40 nanometers, the switch chips were around 65 nanometers. And then the CPUs were able to go much more smaller at a much faster clip. And then finally around, I would say, 2016, 2017 is when the networking space or the ASICs were able to catch up to some degree. So today, we are shipping 60 nanometer chips, and by next year, you will see shipping 7 nanometers chips over here. So again, the improvement in die, and what that does is that it improved the number of transistors you can fit in the ASIC, and which means more densities, more ports. To give you an example, in 2012, A normal router you would look at, you'll see the density supported is around 36 ports of 10 gig. Today, 36 ports of 400 gig is actively being shipped. Right? So that's the advancement of the die design that allows not only be able to support larger scale, more features, be able to support more ports in a small form factor. So now if you look at the technology, as merchant silicon is evolving, the question is that how is the optics going to evolve? Right? So the applications require more and more bandwidth. The merchant silicon is allowing companies to give you faster scale at a less cost-effective price. And then to add on that, optics becomes a big question. Is how is the optics going to evolve? So that's where the 400 gig ZR and ZR Plus came in and into the marketplace. So 400 gig ZR is actively being shipped today. ZR Plus is going to be will be shipping in the next, I would say, 9 to 12 months. But again, the 400 gig ZR is the first industry non-proprietary design. So today, if you look at the optical systems, line systems, if you're looking long distance coherent optics, it's all built on proprietary designs where you cannot mix and match different vendors or different products together. So the industry saw that, and then they saw a need for an open design to be able to deploy to support long distance optics, and that's where the 400 gig ZR came in. So what exactly is 400 gig ZR, right? So 400 gig ZR, again, as I mentioned, is the first multi-vendor DWDM standard, right? It's coherent, it's tunable, it's pluggable. So you don't need any large OLT systems or shelves to do that. You can use a traditional router or a switch as long as it can support the power requirement and the cooling factor of the ZR or ZR Plus optic, and so that the price delta just shrinks tremendously, and so that you can deploy a very cost-effective 400 gig and 400 gig backbone using ZR and ZR Plus, depending upon the distances we're talking about here. So if you look at the max power requirement for ZR Plus is 20 watts. For the ZR optic, it's around 15 watt over here. So this chart, we are showing that if you look at what has happened to on the price for the optics, right? So over here, you'll see that the 100 gig sales price, an average sales price, has been dropping, along with the 200 gig average sales price, right? And the 400 gig as well, but not as fast as the big customers and cloud customer service providers are looking for. And with the introduction of 400 gig ZR, again, the price per gigabit is going down to 10 gig, right? So it's a very large price compression that you're going to see with the 400 gig ZR. And the biggest reason being is, again, you're building on top of merchant silicon, and then you have industry standard optics now versus proprietary optics. So if you look at the ZR and ZR Plus optics, what's in the chip, right? I mean, it's you have the FAC block, you have the dispersion compensation, but again, it's all standard, right? It's all published. We are going to announce 400 gig ZR based systems in OFC by March of this year, so you'll hear more about that as well. But again, standards are set, and there are companies shipping this product as we speak. So why pluggable form factor, right? So biggest reason is that it gives you the ability, right, and it be able to agility to deploy these systems in any form factor you want, whether it's 1RU, fixed form factor, whether it's chassis, you name it. You can source from a wide variety of places, right? It doesn't have to be from the vendor, from the hardware vendor itself that is building the router or the switch. You can source it from other sources and be able to plug and install it and run with it as you would do it on any other different optic. So today you have SFPs, SFP pluses, QSFPs for different technologies. This is exactly where the ZR and ZR plus is heading for coherent and long-haul deployments as well. So 400 gig ZR plus is up to 1,000 kilometer reach, right? And the DSP is in there, it's 16 COM, 400 gig DSP. And on the ZR can up to 100 kilometers, right? So anywhere from 100 kilometers to 1,000 kilometers based on fiber, the capacity, and the noise on the link is the ability you can support that. So now if you look at the ZR and ZR plus, right, the reach is this an example map of Europe. And if you look at here, I mean, can cover pretty much the entire Europe with this optic. So now you can have a point-to-point systems with two routers, two 1RU routers and both ends, and be able to ship 400 gig worth of bandwidth between them at anywhere from 100 to 1,000 kilometers. If you map it to the US, right, there are very few places in the US where you cannot go that long of a distance, especially around the Midwest and the Rockies. But beyond that, if you look at the East Coast and the West Coast, you can pretty much cover the entire spectrum of the US with these reaches that is going to be available in ZR, ZR plus. And if you translate to the region where SANOG is, where say India and Pakistan and Bangladesh, pretty much with this reach, you can deploy it across the board. The only places where you may have challenges is undersea cable. But now, if you're looking at Pakistan, for example, and we're talking about digital transformation, you have to be able to deploy a very cost-effective solution. The only way that will give you the price per bit that is required in a country like Pakistan is to be able to use merchant silicon and be able to use open protocols, and along with open standards like 400 gig ZR and ZR plus. And if you look at the pricing of these systems, it is going to be able to give you the ability to have a 400 gig backbone in the next, I would say, 12 to 18 months. Now, if you look at the 400 gig ZR optics, so what type of optics are out there that you can use to deploy? Right, there are two standards out there. One is OSFP and OSFP DD. And over here, we're talking about OSFP, and the reason being OSFP came into being is that it has the power envelope to be able to support the ZR plus optic. If you recall from the past slides, a 400 gig ZR plus needs 20 watts of power envelope, which means it needs to be able to have enough space on the device to be able to cool it down. So there are two standards, OSFP and QSFP DD, and you'll see that both of them are coming out. And there are advantages and disadvantages versus one versus the other over here. Now, if you look at the coherent bandwidth by speed deployment, the same chart similar to what I've shown in the past is the adoption of 400 gig. As 400 gig permeates into the industry, and you see more and more of these adaptations, over here you'll see the same trend on the coherent as well. So on the 400 gig ZR summary, again, is the biggest thing is the first multi-vendor DCU standard. Right? And the price performance and the densities gives you the ability to be able to scale up much more faster than what is currently available today. And again, it gives you the roadmap to 800 gig. So today, as we're shipping 400 gig, by next year, middle of next year, you are going to see 800 gig being shipped in volume as well. So on the optics side, again, 400 gig and 800 gig optics over here. On the ZR plus, the power envelope is 20 watts. For the ZR, you need power of 15 watts over here. And again, the power envelope is reaching your traditional high and DWDM optics. Same thing with 800 gig. When you go to 800 gig, power envelope is still 20 watts, which means that there's no saving in power when you go from 400 gig to 800 gig. The power envelope is still required at 20 watts over here. So there's no, from the power side, there's no saving over here. So now, like I mentioned earlier, between the OSFP and QSFP-DD, the biggest challenge that you'll see with QSFP-DD is around power capacity and be able to support 800 gig as well. And when we go to 800 gig, the number of the bandwidth on the SerDes, which powers the ASICs, are going to double. So today, the SerDes on the ASICs is 56 gig. We're going to go to 112 gig. And when we go there, that's when the OSFP optics be able to support that. The QSFP DD optics will not be able to do it. So today, when you're looking at systems to deploy, in places where long haul or in a router is an important role, then you'll have to actively evaluate whether you want to use QSFP DD or OSFP. In data centers, it'd be easier to swap them out, but not so much in the field over here. So different type of OSFP and optics available. So over here, looking at the 400 gig FR4, and then the electrical interface is again 56 gig. That's what the ASICs can support today at 56 gig, and then be able to, these 112 gig is coming down the path in the next, I would say, 12 months or so. So this is an interesting optic over here. It's a dual 400 gig, right? And then 112 gig PAM4 SerDes, be able to support that with 8 channel, and estimated power is 20 watts. And again, this is the 800 gig optic. So the reason I'm sharing all this information is, again, is to be able to demonstrate that the industry is moving at a much faster clip. 800 gig is actively being worked on, and standards are already being worked on to be able to support 800 gig in the next, I would say, 6 to 12 months. A little more information on OSFP, right? It gives you very high density. When I say high density, what it means is that on a 1 RU switch on a router, you can support up to 24 ports of 400 gig. On the chassis, on a 1.5 slot chassis, we can support up to 36 ports of 400 gig using OSFP. So when you're packing that much density in a small form factor, then you have to have the ability to not only support the power, but also thermal as well to be able to cool the systems. So today with the QSFP DD, we can do that with the densities, but as we go to 800 gig and ZR plus optics, then that cooling is going to be very important. So here's a brief comparisons between different technologies, right? OSFP, QSFP DD, and the onboard optics. And again, if you look at the densities, it's pretty much the same, right? And the thermal management is the #1 differentiators you can see between the different technologies, and along with the compatibility. So in OSFP, in order to be able to support QSFP, you need to have that adapter. Not so much in the QSFP DD. That's one of the advantages of DD you have versus OSFP. But if you are looking to be able to migrate to 800 gig and then be able to support backwardly as QSFP, you can use the adapter to do that, and then be in a position to be able to support 800 gig when it comes out. So in summary over here, right? So the 400 gig is the major next step in Ethernet. Right? So along with 400 gig, the merchant silicon scale is there to be able to support not only the ports and the densities, but also the feature set as well. And along with the merchant silicon, we have open standards optics, not only to be able to support in the data centers, but be able to support your long-haul circuits and the backbones as well. So if you combine all the technologies together, it gives you the ability to be able to deploy a 400 gig optic at a much more cost-effective price point, so that your price per gig, instead of going up, it's either remains flat or it keeps dropping down for you. So again, the last slide of my presentation, the easiest way to go fast is to go faster. We have 400 gig today. 800 gig is on the horizon, and you'll see more and more technology trends and the compression of price point coming out and giving you the ability to be able to deploy this. That's it.
So if anyone has any questions, you may ask. So there's a mic, and we can just pass on the mic. So no questions?
Hi, Aftab Siddiqui here. So do you have any practical deployments on the region or in country which are using more than, you mentioned 1,000 kilometer as well for the ZR SOPs?
Yeah, so what is the question again?
So the practical deployment, if somebody is actually using in
Yeah,
operations.
so on the ZR optics, today it's predominantly being deployed in the data centers. ZR is just coming out, and the first deployments of the ZR you'll see is done by the cloud customers. The first application again is DCI interconnectivity, right? There's a data center interconnectivity between the two sites, where the distance is 100 kilometers or less, and also along with metro sites, where the distance limitation is 100 kilometers.
Any more questions?
Thank you for the session. It was very nice. My question was regarding 800G. So is it achievable on 2 pair of fiber? As you mentioned in that slides, that 2 pair can be connected with a single SFP.
That's correct. So that's where the coherent optics comes in and be able to support that on.
And right now it's not on production phase.
No. 800 gig is still out. It's still being worked on in the forums, and the hardware vendors are working on it. The precursor to 800 gig is 112 gig SerDes.
Yes.
Right? So 112 gig SerDes is not there yet, and the precursor to 112 SerDes is the 7 nanometer chip. Right? So if you look at the progression, the 7 nanometer chips are going to come up first, be able to support 100 gig, 112 gig SerDes, and then the optics is going to come in. So I would say we're still 12 to 18 months out for that.
And one more question, maybe it's like something from the theory, but normally what is the reason for the demarcation number? Like we had 1G, then 10G. 40G was not as much popular as compared to the 100G. Then we have 400, and then why we have 800? It's not like, maybe it's like a foolish question, but
No.
on the same page.
Well, I mean, the thing is, if you look at the technology, right? I mean, the 40 gig was very, very common in data centers. Not you'll see as a router in long haul circuits, but it was very, very popular and common in the data centers. But as the technology evolved, right, I mean, it was easier to go to 25 gig SerDes, right? If you look at the speed of those electrical links, we went from 10 gig to 25 gig SerDes. So 10 gig 4 by 10 gives you 40 gig. 4 by 25 gives you 100 gig, right? So the 50 gig is there by 2 by 25, but 75 again is that number was pretty odd. So it lines up the speed of the SerDes, right? So as the SerDes speeds goes up, that's how those ports are coming out as well. So now we had 56 gig SerDes, which is giving you 8 by 50 gig is 400 gig, right? So that's so if you look at here, if you look at the Moore's law, right? The Moore's law says the doubling of capacity every 2 years, and that's exactly what we are doing.
Okay, thank you.
Thank you. A big round of applause for Mr. Atif. So moving on the next speaker, who is going to share the state of global IP4 routing table with us. Please welcome Dr. Philip Smith, Chair, SANOG Program Committee.
So good morning, everyone. Well, it's good afternoon now, actually. Oh, well. This is going to be my 6th monthly annoying presentation, I think, once we get slides. So yes, I mean, for some reason, I keep doing this at every SANOG. It's completely different from looking at optics, which I think is way more exciting than looking at this. But actually, this is very important as well. And I mean, as I'm sure as several of you know, it started off as a hobby, and I moved from the UK to Australia in 1998. And the one thing I noticed, I mean, growing up in the European internet of the day, you know, the CIDR report was a well-known report at that time. Tony Bates had started it when he was at the RIPE NCC in 1994. And it was all about encouraging people to move from class full to class less routing, so starting to aggregate address space together. And of course, moving to Australia and looking at this Asia-Pacific internet, there were no operators appearing in the CIDR report, so it was kind of, well, are there no operators there because everybody is perfect, or are there no operators there because the internet's quite a bit smaller in this part of the world? And actually, it was more the latter, that the network was, or the address space being announced was smaller. So with the help of APNIC, who provided a lot of the facilities, I started having a look. And it kind of, if I'd known that it was going to be still something I was doing today, I would have probably been a lot more formal and less kind of random in putting all this together. So it still looks a bit like a hobby because actually it is very much still a hobby. I've started recording the V6 table back in 2010. I think when I started recording that, my idea was to expand the report to actually do V6, but in the last 10 years, I've never really got around to doing that. So it's very much still V4. Not that things are perfect in V6 either. I've got some V6 bits and pieces through this, but as you'll see there, V6 is heading in the same bad direction as V4 is as far as the routing table is going. So I've tried to make this a bit easier to read over previous ones. So just size of the table, this was, what's today? Yeah, this was yesterday. But 791,000 prefixes in my view. This is at APNIC's router sitting in Japan. This is at Dixie, which is the wide operated exchange point in Tokyo. Of course, the view of the global table looks different every single place you look at it. So this will probably be 20,000 prefixes plus or minus what you see. And the thing of note, which I'll come back to, is on the second line there. I don't think you're going to see this pointer, even if I try and use it. Does it even have a pointer? Anyway, no, it's not going to work even if you try. So what I'm going to come back to is the second line over on the right-hand side there, 301,000. Now, this is what the global table would look like if everybody did aggregation. So you could probably safely say there are 490,000 prefixes of junk filling up your routers that are of no earthly use to anybody at all, anywhere at all. But the global internet seems to be very happy with carrying around a routing table that's probably 65, 70% full of junk. So there we have it. So I measured that. It's about 2.6 times bigger than it actually needs to be. And the various other aspects through there that we'll just look at. If you look further down, maximum AS path prepend. So AS 53176 has decided that doing 31 times prepend of the address they announced to the internet is a good thing to do. I mean, those of you who know BGP will probably wonder what on earth a 31 times prepend can achieve. I've no idea. And I teach BGP to quite a lot of operators around the region. So they might have a good reason for it, but it makes no sense to anybody else. And so on. Let's run through it. Asia, the APNIC region. It's about 210,000 prefixes visible here. After we do some aggregation, we can pull it down to 61,000 prefixes. So again, 150,000 prefixes of junk floating around on your routers in the Asia-Pacific region. You can try removing all those junk prefixes, and you'll find that it will still work perfectly well. So again, that's just the summary of some of the things that we see there in V4, in APNIC region. Globally, this is just the top 20 list. So this is mimicking the CIDR report, top 20. These are not the top 20 biggest ISPs. Their marketing departments might think they are, but in reality, these are the top 20 worst operators globally. These are the ones who are laziest, make no effort to aggregate the BGP announcements to the global table. So the worst one, Uninet, this is the Mexican Research and Education Network. They're announcing over 6,000 prefixes. If they did some aggregation, we could pull it down to 600. The next biggest is Uninet in Spain, another RNE network. TPG in Australia, Australia's third biggest provider. Again, massive, rampant deaggregation for no reason whatsoever. Chinese Research and Education Network, and so on we go through the list. If we look in this part of the world, actually I've got that coming up a bit later, but I've colored it according to which registry region. So we can't just point to, oh, it's South America, or oh, it's Asia or Africa. Those in black and in pink are from Europe and North America. So you can see some of the global announcements, at least as far as I see them. What else is next? This one's interesting. We're going to come back to this later on today as well. And there's quite a big fuss about a lot of this as well, if you're following any of the mailing lists about routing security. We're going to talk routing security this afternoon. We're going to have a tutorial all day tomorrow about it by FTAB. And the workshop is even going to be looking at some of this as well. So there are currently 443 unassigned prefixes in the global V4 table. This means these are prefixes that are not assigned to anybody at all. So some people have just decided, oh, they're not assigned, I can just use them. Why are they able to do that? Why are there upstream providers who are accepting unassigned address space and are quite happy to route it? You wonder where all your spam comes from? You wonder where all the illegal use of the network comes from? Start looking there. And look at the AS numbers as well. There are 385 AS numbers that are not assigned by the registries, not assigned by anybody at all, that are there in the unused space that some operators have just decided to use. And they're transited by these well-known, reputable operators as well. I mean, why are none of the operators actually checking any of the address space or any of the AS numbers that they receive from the customers? Is it money more important than the integrity of the network anymore? So these are the complete list of unregistered AS numbers. I thought I'd try and do a list of what they all were. The ones in red are the documentation AS numbers. These are AS numbers you use if you're writing, instructor notes for workshops or internal training for your staff and so forth. But some people decide that we should announce them through global internet because it's, well, I don't know why. Is it fun? They seem to be doing it. But all these other AS numbers are not registered. Look them up. Go pick any of the 5 registry databases. They are not there. So I guess people are just deciding, well, it's not in the registry database. It must be free for me to use. Quite a few in all that. What else? So I've just picked some of them at random. I mean, my report summarizes them according to, in sequence of the address space announced. So, AS 17076. So that's being originated, but it's being transited by level 3. I think level 3 is a reputable provider, aren't they? So why are they accepting this? Well, what filters do they have? This is being webcast, so hopefully somebody from level 3 can explain why they're accepting unregistered AS numbers into their network. If we can't get the big providers to validate the address space and AS numbers in use, what chance do we have trying to explain anybody else? I'll leave FTAB to explain that one to people in the tutorial tomorrow. But, this is a huge list. Have a look at the My Routing Report website. You can find the complete list there. As I say, on the right-hand side, a lot of those are not unknown operators. These are the big transit providers. What are they doing? The unassigned addresses, again, the list is too big to try even fit on the screen, but here are some. Transit Cogent, Hurricane, who else going through? Time in Malaysia. Who else do we have? We've got Telefonica in Spain, GTT in Germany, Equinix, originating address space unassigned. A big discussion at various conferences about, I need a letter of authority from my provider. What letter of authority? I mean, Maz has presented at SANOGs before about how easy it is to fake a letter of authority to pretend you're from anywhere. And then that's usually enough for a provider to just announce an address space based on fiction. So here's all the address space that's, it's an example of the address space that's just being originated and not registered to anybody at all. Okay, back to equally serious things. So the global table is still growing. The big growth is in /22s, /23s, and /24s. 24s are no surprise. It's probably the smallest routable V4 address size that we can actually get. But as you notice as well, 25, 26, 27, 28, 29s are also being routed as well. And yesterday we had even 190/32s appearing in the global table. Whereas you compare with, last year, whereas this year you can see all these are being filtered out. Right? So you can see how the growth is going. I think maybe the upstream providers filtering it between 2019 and 2020. But the big growth, if you look at the highlighted in the red circles, ellipses, the growth is in /22s, 23s, and 24s. I mean, given what RIPE NCC and ARAN have no more address space to hand out, and nor does LACNIC for that matter, most of the address space assignments you're now seeing are from APNIC and EFRINIC, and the allocations that those two registries are making are 23s and 24s. So it's probably no surprise that that's the remaining growth that we see. What else? V6, it's the same mess in IPv6, I fear. /32s, 13,000 are out there. I don't think any registry has handed out 38,000 /48s. I mean, there's a /48 end user assignment. There are probably a few thousand of those have been done. The rest of it are network operators taking the /32 and chopping up into pieces. For your homework, or maybe your lunchtime work, how many /48s are there in a 32? It's a big number. So if every operator with a 32 chops them into 48s, the only happy people left will be the router vendors, who will sell you your routers with terabytes of memory in them, if you go and do the sums. So this is very scary. And so again, we have a look at the growth. Did I put arrow circles on there? So the /32s, 12,775 in there. And the 48s, 34,000 /48s. Compare it with 10 years ago. 9 years ago. 7th of January, 9 years ago. The V6 table was pretty small then, but this was after all the IPv6 days and IPv6 launches and IPv6 weeks and so on that we had been doing. We see the big growth in /48s. It seems like the minimum routable address space is the only interesting thing that people want to announce. And so there are the comparisons over those years. Global V4 table, onwards and upwards, not much change, pretty boring. The global V6 table is kind of stumbled in the last few weeks. I'm not quite sure what's going on. It could be the end of your holidays and whatever else. It's slowed in probably the last month. I'm not quite sure really why. It showed a bit of a jump, and then it's slowed up there. The growth in autonomous systems, onwards, upwards, it's steady. It's pretty much linear. The aggregation going on, so the blue shows the global V4 table. The green line is what if we aggregated it as aggressively as we could. I'm not paying attention to traffic engineering needs, in case any of you are wondering. This is purely taking the table and aggregating it as hard as I can by origin AS. And then the red line shows unique prefixes. What that shows is operators who are taking the aggregates and dividing them into pieces, but then not announcing all the pieces. They're missing out bits of the pieces. I'm not quite sure why people do that. If you get an address block from the registry, the idea is that you announce the entire address block. Because if you don't announce it, somebody will spot that the bit's unused, and they will happily misuse it for whatever they want. And this won't show up in my report, because my report is only spotting address space that is not registered. It's not looking for address space that's registered and not announced. So it's a big danger. If you have address space and you do not announce it, somebody else will. Case in point, I'm involved in doing the Apricot conference. If we don't announce the Apricot conference address block globally, 365 days a year, somebody else will borrow it. Right? They will borrow it, they'll announce it from some random AS, usually in, places, Europe, wherever, Eastern Europe, and use it for whatever, maybe spam or DOS attack, sourcing, or whatever. But we have to be very careful, So the conference address space that's used in the Asia-Pacific region, it must always be announced. When Apricot's not running, APNIC originates the address space from their infrastructure in Brisbane. Otherwise, somebody else will end up using it. So it's very important. If you've got address space, you must announce it, because somebody else will do that if you don't. So that's why we see the difference. The red line should not be above the green line, but it is. Prefix sizes, as I was saying, 22s, 23s, onwards and upwards, no growth in anything else. In fact, the 19, 20s, and 21s are pretty much flattened altogether. Slash 24s, as I said, onwards, upwards. In V6, comparing the 32s and 48s versus the global table, 32s, not much growth. Even though that's the minimum delegation to network operator, we're seeing 48s. People love subnetting to the smaller sizes for some reason. The V4 address space announced, it's kind of interesting over the last 2-3 SANOGs, we saw the size of V4 address space actually dropping backwards. And it's kind of flattened out now. So I think we've flushed all the V4 address space globally out into the global internet. Even though there's a lot of V4 addresses being traded and handed out, round and about and so forth, the total global space we see being announced has flattened, and probably for about the last 3-4 years now. AS announcements, nothing interesting there, onwards, upwards. Maximum AS path length, this is always amusing for me as a presenter and for the audience as well. Why somebody needs to do a 214 times prepend, nobody has any idea, but it seems to entertain quite a few operators, whether it's those who do it or those who watch it. If there's a good BGP explanation, I've been asking for this now for probably 20 years, still waiting an answer. Looking at the deaggregation, so there's the URL you can have a look at, time.apnic.net. Look in the current space, the current directory. And that lists pretty much all the analysis that I've been doing, and I've got a lot of historical stuff in there as well. In fact, it goes all the way back to 1999, if you can be bothered to have a look. And you can see a lot more of that data sitting there. So one thing I do is I work out the deaggregation. In other words, take the address space in each registry region, aggregate it as much as I can, and then compare with what we actually see in the BGP table. And of course, the global value has been going upwards and upwards pretty much since I started doing this. So the other day when I was putting those slides together for this conference, global deaggregation is 2.63. When I started, it was about 1.8. Now it's 2.63. North America and Europe are fairly stable. They're creeping up slowly. Asia and Pacific region is going up a bit quicker. Latin America and Africa, well, rather than trying to explain it, I think a picture is better. So the orange one at the top, there's LACNIC. So Latin America, Caribbean. So this is mostly South America and the Spanish-speaking parts of the Caribbean. You see what happened about 3-4 years ago? There was a big effort to improve aggregation. There have been quite a few individuals working in the South America community to help the operators do a bit better aggregation. So that deaggregation has improved. Africa is all over the place. It was showing improvement a few years ago, then it's all gone bad again. There's some theories about the prevalence of exchange points and prevalence of backbone carriers and all the rest, but I don't see much correlation to exchange points happening or even big carriers happening to the deaggregation that's going on. In the APNIC region, the deaggregation factor is flatlined and is starting to drop. There's some efforts being made in parts of the region, not South Asia, but other parts of the region to improve aggregation. Whereas, Europe, North America is generally pretty steady. So look at the Asia-Pacific aggregation savings possible. So the biggest savings, these are the biggest savings that could be made. Or the biggest deaggregators, if you like. So it's the top 20 operators. So as I mentioned before, TPG is up there as the worst in this region. Then we've got China's Education Research Network. Interesting enough, the CER net is only, in my view, in Japan. If you go to North America, I don't see them there. So there's something odd happening with their BGP announcements as we see them in Japan. So haven't got to the bottom of that one. Vietnam, so VTEL and VNPT, just whatever prefix we have, we just announce them as much as we can. We've got Guangdong Mobile, Telecom Indonesia. In this part of the world, when our usual favorites, Bharti, Tata, BSNL, creating a mess of the network. And then we've got SIFI a bit further down the list. And then Connect here in Pakistan, appearing in the Asia-Pacific top 20. So this is deaggregating. For Pakistan, just for fun, so these are the top 20 here. So Connect could do the biggest amount of savings just by having a look at the BGP. I don't know why 1,037 prefixes need to be announced. You only have 2 submarine fibers going out of the country. We heard about the third one that's appearing soon. So why we need to deaggregate wildly like this, I have no idea. Cybernet, same question. PK Telecom, same question. In fact, pretty much all of you there, same question. Why, if we look at Brain PK, announcing 68 prefixes, if we aggregated, we could save the global internet 60. Now, you might say, well, this is tiny compared with the global deaggregation of 400,000 prefixes of junk. But we have to start somewhere. When there's no need to announce all these subnets, then don't announce them. You're not gaining anything. If it's traffic engineering, you don't traffic engineering by take your big address space and chop it up into 24s. That's not traffic engineering. That's pretty much taking a shotgun to the whole internet. I mean, that's as blunt as I can make it. There's really no need for doing that. If you're following industry best practices, none of you would appear on this page. So please, if you can help tidy some of this up, because it looks pretty bad. So general observation, V4 table is carrying on growing onwards, upwards. Still linear growth, has been for the last 8 years or so. Total address space, as I said, has leveled off over the last 3 years. There's no more address space appearing in the global internet, but we see the routing table still growing and growing and growing. So it's kind of interesting. 24 announcements carry on growing. So operators are just deaggregating. I'd love to know the reasons why. Is it really all traffic engineering, as some people try and say? And I know you come and talk to me at lunchtime saying, oh, but Philip, it really is just traffic engineering. And I'll say, well, no, it really is not traffic engineering. There isn't any new traffic to engineer over. It's BGP operational practices, BGP best practices. Right? So take a look at how the routers are configured. A few years ago, I'll tell the story of China Telecom. I mean, they appeared always number 1 in Asia Pacific, and a concerted 3-4 years effort by their team managed to get them off the top 20 list. So it is entirely possible. You just need to look at what you're trying to do. What about V6? Well, I think industry standard seems to be whatever we do in V4, we do in V6. Now, I know we teach it in the workshop that IPv6 is nothing really strange compared with IPv4. It works the same way. Just got bigger addresses, and they've got colons rather than dots. But people seem to be taking the V4 bad practices in routing and applying them to V6 as well. The problem with V6 is the address space is vast. As I said, how many /48s are there in a /32? Have a think about that, and then we can talk about it if you come to the workshop or the next SANOG or whatever. Anyway, that's all I have. Hope it's interesting, hope it was useful. If there are any questions, happy to have questions. If not, we should move on.
Thank you, Philip. It's more of a comment, a question towards the audience. Quickly, one thing. How many of you knew about CIDR report before coming to this session today? At least now you know. I can see a few hands, and I mean, those hands are my mentors. So, and I learned from them. So it's like 2007, 2008 when we started learning this. I've been reading it every day. So I quickly checked the statistics today. If you go back to the unassigned V4 address space, there are 2 organizations who are announcing unassigned address space, and they are in the audience. Make sure that you look at it, that what's happening. It is working today. I can tell you it is working today. But if you are taking interest in policy, then a policy last year was passed that any unassigned address space, APNIC will create an address, AS0 ROA. And because of that, Google and Cloudflare, by the end of this year, will stop accepting your prefixes. It is working today, but it's not going to work for a very long time. So if your BGP practices are like the way Philip explained, it's not going to work. So, and now coming back to Philip, how do we demystify these myths of traffic engineering is to /24? How do we make the change? I mean, are there any 101, a one-pager 101 to explain how can you get rid of the /24s?
And I don't know the answer to the question. I mean, I've been teaching BGP workshops since 1998. And it pretty much means I've completely failed in what I'm trying to do. People seem to understand that traffic engineering is just taking whatever address space you have and spraying out 24s. And a lot of places I go, people say, oh, but it works. And I don't know what works. I mean, we find a lot of interesting stuff. I mean, I haven't looked at any of the BGP stability. I took that out for the presentation because I wanted to look more at some of the unassigned addresses. But if you look at the instability stuff, people are buying these automatic load balancers, for example. And what the automatic load balancer does is you give it its address space, and it just starts chopping out in 24s, announce withdraw randomly on different external links. And it's not just me. Quite a few other people have pointed out, get rid of these pieces of junk from your network. Don't buy this stuff because it is destroying the stability of the network. I mean, there are a couple of operators in South Asia who swear by them, at least by looking at the instability of the table. And quite a few people have said, don't buy this stuff. There's no replacement for you sitting down, understanding how your address space has to be announced and has to be routed properly. So, I mean, another big story, especially from South Asia, is that, oh, I only want to announce the address space when my customer is using it. If I don't assign it to anybody, then I'm not going to announce it. And that's the same thing as, oh, so if you switch off your mobile phone, the mobile operator will disconnect your number. Well, no, when you switch off your phone, you kind of hope that calls go to voicemail. So if you don't announce your entire address block, somebody else will use it. Right? They will use it. I mean, Aftab's going to talk more about RPKI and so forth, and I'm going to talk about it this afternoon. It's desperately important that everybody here signs the ROAs. Desperately important. Because if you don't do it, very, very soon, any address space that you have that you're not using could well end up being invisible on the network for various reasons. So announcing random 24s out here, there, and everywhere is really not going to be a good future. We need to sit down and try and do our traffic engineering properly. Otherwise, I mean, I'm happy to do more BGP workshops, but there's only a few of us, it seems, globally who are doing these various workshops. Even at Apricot coming up next month, we were told, oh, no, we don't need BGP workshops. Everybody knows how to do BGP. And I'm like, look at all this, and I go, really? I'm not convinced. I'm really not convinced. So, sorry, Aftab, I can't answer your question, but, I'm open to ideas.
Hello, Philip. My name is Samir Ali Khan, and I am currently working at Karachi. You mentioned earlier that there are currently 443 unassigned, prefixes in the IP4 routing table. Now, my question is a bit different considering the kind of requirement that we have. For example, there might exist organizations out there globally who might not necessarily announce their own subnets. They might go to a data center and authorize them to announce those subnets. So when you mention or when you say that there are 443 unassigned IPv4 subnets, are you mentioning that me, as an organization, am not updating the RIR who is stable? Because every RIR has a different policy of controlling things. For example, like as far as my experience goes, RIPE has probably the most strictest policy. They won't allow you to announce subnets until and unless you update the whois of the RIR properly. But like, I found Aaron to be the most lenient. They won't actually even ask if there's an entry that exists that I, as a party, would like to authorize a particular organization to announce the subnet on my behalf. So when you say they are unannounced, like from a perspective of somebody who doesn't announce them, but who actually owns them, how is it more applicable on that part?
Okay, so there are two different things here. What I'm looking at the 5 registry databases. I'm looking for all the assignments that the 5 registries have made. In other words, they've taken address space out of their pool, given it to a member. And so when I look in the global table and I see address space that has not been delegated by the registry to a member, I'm displaying that here. So I'm not talking about entries in the routing registry. Right? Yeah, you're right. You know, RIPE NCC is very strict about what goes in the routing registry. So routing registry is one side, but it's an actual allocation database, what each of the 5 registries has given to a member.
Okay, so like the next question is far more interesting, because we have had scenarios, because we do not announce our own subnets. We ask different data centers in Asia to announce those subnets for us and route them to the servers so that our users can use those IP addresses. The question is, we have had scenarios where an organization from Israel hijack some of our subnets that we just unannounced from our network because we were going through an activity. The activity lasted around 45 days. And during those 45 days, they were around like 10/24s that, you know, that organization in Israel started announcing. And we had to contact APNIC, and we had to even contact RIPE in that case, that these subnets are owned by us. They have been issued to us. We have unannounced them because there was a need on the network for an upgrade. There was a project that was winding up, a new project came in. And in that case, you mentioned earlier that there is a letter that you can give to different vendors that can be replicated. In our case, like we call it a letter of authority, where we ask the particular data center to mention their AS number, and we mention the subnet in that LOA, but obviously it can be photoshopped or it can be edited by a number of people. But that is how we are currently doing it. So for organizations like us who issue these letter of authorities in PDF formats to different data centers, and the case that we had where an unannounced subnets for 45 days was hijacked by somebody. Now, these scenarios are going to come. There might be situations when we have to unannounce subnets, and they would be left unannounced for a certain amount of period. Do you recommend, is there a best practice where we are like, ideally, you should leave these subnets unannounced for like just 15 days, because after 15 days, there's no guarantee that somebody else is going to announce them. So is there a best practice about it?
There's a best practice, and it's called RPKI, right? Signing your origin. If you sign for that prefix, that subnet, which autonomous system is allowed to originate it, any operator who's checking the validity of the announcement will accept the announcement, and anything else, you know, there'll be, so if it gets originated from anywhere else, any other autonomous system, they'll drop it. So the industry best practice is RPKI, so hence the ROAs and route origin validation.
But in our case, like we asked the particular data center to actually unannounce them, and we had to change all the whois information in the RIR as well.
Yeah.
So like we came into a situation we had to intentionally left that subnet unannounced.
Yeah.
So like should we never do it, or like even if like we're not announcing it, should we still leave the RPKI updated?
Yeah, you need your covering aggregate, so sign the origin for the covering aggregate. And when you need to use subnets, sign the origin AS for the subnet that you're going to use as well. Never ever sign anything that you're not going to announce, because then somebody can just fake your origin AS. Right, you know, you can sign it. So if the data center with their own autonomous system, you sign it saying this autonomous system is allowed to originate this subnet. I didn't show it in the report here, but there are a lot of operators, especially big data center operators, who are subnetting a lot of their address space because they're announcing in lots of parts of the world. If you need to do that, there's nothing else you can do about it. What I see in a lot of the routing announcements is you've got one operator, transit provider, who basically gives a 24 to one customer, 24 to the next customer, and just lets the whole lot go out to the world. Whereas in fact, what they should be doing is only sending the aggregate out. So what you have to do is perfectly legitimate use of the network. But the fix to the problem that you experience with the prefix hijacks is that sign the ROAs, and next step for you, do route origin validation. The more who do that, then the less chance people have of hijacking unused and unsigned address space. Anyway, we should let the next speaker talk.
Just for one
anyway.
question. Yeah.
Yeah.
My name is Farhan. I'm from National Telecommunications. So my question is a bit regarding the 5G side of the network. Although it's a XX technology, my question is that with the advent of 5G, how do you think the routing is going to be evolved? I mean,
Goodness.
although it's a bit different side from your area of expertise because you're mostly in the routings and BGP sides. But do you think, how do you correlate with the 5G side and the routing side?
Well, I mean, as far as the global routing system goes, I don't think nothing changes with 5G as far as routing goes. A lot changes with the network design within the 5G infrastructure and how it connects to the service provider backbone. I mean, with 3G, 4G, we're quite happy with NATs and big latencies and all the rest, but the 5G spec is talking about millisecond and so forth around trip
Low
times.
latency.
So that has a big impact on how things. So for the mobile operators, they have to have a very close look at how the infrastructure is actually designed. But from the routing and the BGP point of view, it's same as 4G or 3G. From the data perspective, you've got a big address block. 5G has to be IPv6. I mean, you cannot realistically try and do 5G using IPv4, not enough address space. You've got NAT, which adds big latency into everything as well. So all that stuff has to come out. So using V6, you're going to give V6 address blocks to every single mobile handset. A lot of mobile operators are doing that around the world as well. So that's, in the opening we talked about V6 is going to facilitate a lot of new stuff. Not because V6 is some magic new technology. Using V6 means we don't have to use NAT, which slows everything up, down, and really makes it hard to scale the network properly. V6 gets rid of this NAT box and lets us scale things for the future. So, but from the routing point of view, we're still going to have the big address block. But you can't announce every single /64 that every mobile phone is going to use. You've got to announce the covering address space that you'd give to the mobile network.
Yeah, just one thing that, that 5G standard actually says that you need to achieve 1 millisecond latency.
Mm-hmm.
So from that perspective, I mean, how do you think that the routing, different routing algorithms can improve or minimize the latency? Because the target is to achieve the 1 millisecond, which is very, very ambitious target.
Yeah, but it's within the network. So from the handset to access within the mobile network. So. But from the global, it's not like it's going to be 1 millisecond global. It's not going to be 1 millisecond here to London. Impossible. But within the mobile network, yes. But that's a separate discussion. But as far as the routing goes from the mobile network to the rest of the infrastructure, what we have will scale as long as we avoid the temptation of the bad practices that I've been trying to highlight here. Sounds like we need a 5G mobile network design session at some point. So we did talk about PKNOG, dropping a hint. Get that going and running, we can do a lot more things like this for benefit for everybody. Anyway, now I really must get off the stage.
So, thank you, Dr. Flip, for the informative session and keeping us up to date. And Dr. Flip is with us throughout the workshop, so if you have any further questions, you can have a chat with him anytime. So moving on to our final speaker, please allow me to introduce Mr. Asad Ali from Inbox Business Technologies. And he will be sharing his insight on DDoS, which is a concerning factor for all the network service provider as well as ISPs. And he will discuss some of the mitigation and prevention techniques. So please welcome Mr. Asad.
Good afternoon, everyone. So the topic given to me for the discussion is DDoS mitigation. I will be discussing different methodologies and the techniques which are available for the ISP and the enterprise to cater for or to manage the DOS attack. So if you can see on the slide, it says DOS and DDoS. So I want to make a distinction right over here. DOS is basically an attack technique where a single entity is attacking a single, there's a one victim and a one attacker. So for a distributed DDoS, this definition changes to multiple attackers are generating attack to a single destination, or it could be a multiple as well. So this is just for the distinction. In further slides, I will be discussing with examples as well. So for a brief introduction, I am working in Inbox as a principal architect, and I have otherwise 12 plus years of experience in information security, working in security architect, network security, SOC, and SIEM. So, yeah. And this is a brief outline, or you can say agenda of the presentation. There will be challenges in the existing approaches of managing DOS attack, and what can an ISP do at its own end, and what can enterprise do to mitigate this attack. And then there are some free available options from an open source community where we can detect and mitigate the attack vectors. So giving it is starting with a very simple example. So if you take internet as a highway, so in the lower bottom you can see the good traffic is coming in a normal flow, or it coming towards the destinations in an agreed upon protocol or a latency or a performance criteria. But in cases where this traffic is disturbed due to, it could be a misconfiguration issue, it could be due to an attack. When the good traffic flow is disturbed by an attack or a misconfiguration, there is a condition which could be a symptom or it could be a real attack. So the flow of information going from point A to point B, when it gets disturbed either by an attack or by a misconfiguration, it gives up DOS-like symptoms. So it's important to know that it's not certain that every performance degradation issue is a DOS attack. It could be a symptom and it could be a real attack as well. So most attackers use this as a decoy or the diversion techniques. So if you can, I can give you an example of a banking malware. So when a banking malware hits, what they do, that they launch two simultaneous attacks. One attack is for taking out the information or extracting the payment details, and at the same time they are DOSing the fraud system. So those people cannot reconcile, the security team cannot reconcile the differences or the fraud parameters. So this is why it could be a symptom or a root cause. So differentiation between the two is a job of a security analyst or the design team. So these are some of the interesting facts or the overview of a DOS. So ENISA, which is a European cybersecurity agency, it defines DOS as anything. So if I can, okay. So what is not a DOS attack, you have to differentiate between the normal or a business context. That needs to be aligned whenever you see a symptom or a performance of packets going beyond the normal baseline. So on Amazon or eBay, you can see that their sites get a lot of traffic on Christmas or Black Fridays. So the amount of traffic that is being generated, it could be it gives a symptom of a DOS attack, but it's not an actual DOS attack. So having the real context of traffic is very important to make the clear distinction of the GitHub. It is the largest repository of source codes, probably 1 billion lines of code is available on GitHub. So it was being serviced by a cloud provider called Akamai. And Akamai also provides DOS mitigation services for 30 to 40% of internet users. So it was the most severe DOS attack recorded up to till history, which was to 1.3 terabits per second. So the way it was attacked was it used the memory cached servers. So it was an amplification attack where the users were spoofed, the GitHub address space was spoofed, and the memory cache servers, they are basically, you can say, optimization servers for caching, for quick delivery of results, so you don't have to go to the target servers for every request. So the amplification attack does that you have to send a very small size request, and in return you get an amplified response. For example, for a 30-byte request, you are getting like 100 bytes or 300 bytes in return. So multiple sources, having multiple instances of scripts running on multiple nodes, generating that traffic, it can overchoke the upstream link. So this is what happened for GitHub. So now it's from the statistics point of view, you will see that 64%. This is from a Redware and an ERT team. Redware is a cloud service provider, and it provides DOS mitigation or a DOS testing services over cloud. And their ERT came up with the statistics where you can see that the frequency of application attacks have increased from normal layer 4 or attacks. This is because applications are more dynamic in nature. It's easy to bypass, whereas the defenses for layer 4 traffic or layer 4 protocols are more mature or more easily to be mitigated by the ISP or the enterprise. So I will be giving examples of application layer attacks as well, just to give you an idea how it works. This is from the research carried by Penamon and DOS strategies for dealing with growing threats, IDG. So if you can take right in the middle, ease of market. So from an attacker point of view, but from a motivation, you can say, everything has become a commoditized or has become very, the entry to market, or from an attacker economy point of view, it's becoming as a service where DOS as a service is being sold by hackers, and you can buy attack or bots for launching attacks against your victims over the internet. So as it says, for $20, you can launch 300 gigabits per second attack, Think bots, especially Reaper. Okay, so all those bots are managed by hackers, but what they do, that from the internet underworld, I'm sure you are aware of it, that you can buy these bots through Bitcoin, through other means as well. So you can this makes the customer more vulnerable to the point that they don't need to build those tools. Those tools are already built, and they are being serviced by these hacking communities. So from the most the most common category of attacks, which are probably worth mentioning here, is UDP, and which are layer 4 attacks, and then the application attacks. So volumetric attacks, and then there are attacks which are protocol targeted. So you need to know that there are some attacks which only happens at certain layer of the network. So knowing the network is more important to have the right defense as well. We will be discussing the architecture or the threat landscape, so where each attack is applicable and where the other is not. And at the last, you can see from the solution perspective, the research shows that customers are in the process or in the habit of now placing inline DDoS solutions for the protection. This is because ISP can only guarantee you at layer 4 traffic protection, but for application attack, that is mostly the responsibility of an enterprise. So inline solutions are protecting your target infrastructure from all layer 7 attacks or layer 7 DOS attacks. And from the financial point of view, this is then again, as the research highlights, that the maximum downtime or the maximum penalty due to the downtime which has been suffered by an organization has reached to $50 million. This could be due to direct and indirect losses of non-availability of critical services. If this is Amazon, so this numbers makes sense, because their SLAs and their e-commerce is all generated per second, per hour. So availability is a critical factor for them. Now coming up with a few examples, because it's important to understand that how these attacks work at a protocol level, so your mitigation and defenses are made accordingly. So this is an example of a protocol attack which is use the three-way handshake. So the three-way handshake normally is, as everyone would know, is made of three packets coming from client and servers to complete the handshake. But in this scenario, the handshake is never completed. The attacker is continuously sending from spoof addresses SYN packets, and in response to those SYN packets, the attacker is, the victim server is opening up space or window or buffer, and it's waiting for those replies to come. Since those are all spoof source addresses, the reply doesn't come, and in a very short interval, that buffer is overspilled, and all the traffic or all the legitimate traffic which comes in is being denied. So in order to mitigate this attack, you usually do a SYN cookie, which is a flag or a hash, so that it's calculated using source, destination, IP, and port. So once that hash is sent by the server, so it expects the client to send the same flag or the same hash for the corresponding communication. Unless that cookie is not sent by the client, it will not open the corresponding connection. So this is a SYN cookie is a mitigation technique for SYN-based attacks. This attack is very common, and it is doing a lot of damage over the network or over the for the customers as well. So what happens that if you can see on the reflectors, so reflectors are anything which is a server, a DNS, FTP, NTP, which has a amplification factor. So what is the amplification factor? You send a small request, and in return you get a large response back. So an attacker can spoof your addresses so that it comes out that you are sending the request. That request would be 50 bytes, 30 bytes, depending upon what protocol you are targeting. But if multiple attackers can do it from multiple machines or across nodes, and each node running multiple scripts or versions of that attacker tool, it can very easily overwhelm the uplink or the upstream, which is probably, if you can then take example of a DNS attack. DNS attack have an amplification factor of 50. So with a 1 gig throughput, an attacker can generate 50 gig of amplification attack towards the victim because it has a amplification factor, as I mentioned, of 50 bytes, and you just have to change the DNS QD type. So instead of sending a record resolution request for a particular domain, attacker would change it, and it will say that give me the record resolution for across all domains and put in any record request. So it's just a manipulation of protocol and the request. You can generate a lot of traffic using this. And this is an attack which is layer 7, and it is called slow loris. So slow loris has been very widely used to downgrade the performance of your of the attacker servers or their machines. What it happens that it's a GET request, but the GET request is not completed as per the RFC requirements. What it does that it delays the completion of the GET request. So if you can see those 3 dots, these 3 dots donates that it is a continuation of an header, which is a fake header. And it's according to RFC, this doesn't have any meaning. But what it does that it opens a connection stream, a continuous connection stream to wait for the header to be completed. So this hogs the network and the application to serve legitimate requests. This is an interesting slide. I took it from Akamai. Akamai, then again, is a service provider, and also DDoS mitigation. Around 30 to 40% of internet traffic goes through them. So if you want to use DOS as a state weapon, probably this is what China is already doing. So I think you all are aware of the Chinese firewall, which is a censorship tool for disallowing content to be shown on their network, or they can decide what content should be displayed for the outsider and for the inside public. But lately, as of 2016, they upgraded their architecture and they put up another feature which is called Great Canon. So what it does, that it transparently, it injects in the visitor browser JavaScripts where by the policy or by other choices, they can use that JavaScript to target their victims. That could be USA, that could be any other state they would like. So this is all done transparently without user knowledge. And it has a great impact because the amount of, it's an offensive tool, so the impact is not like documented, but from the Akamai research team, they have seen real attacks which has been generated because of finding malicious JavaScripts injected into the browsers. So for the DOS threat landscape, you need to know what's the attack surface. So to know the threat landscape, you need to know what are your responsibility and what attack are applicable across that landscape. So if you can see from the left, this is an ISP. So any ISP has would protect you for a layer 4 attack or a volumetric attack, because and it has a large room or a large pipe to handle those attacks. But as you move further down towards the right, you can see the throughput reducing, or it is measured by a PPS or a packet per second measurement as opposed to the bandwidth or an interface. So all the attacks which are going towards the right will probably test your devices on a PPS scale, like a data sheet of an IPSA that it supports 100,000 connections of HTTP per second. The attacker will program to test that limit. So on the right, you are basically breaking up the boxes or testing those boxes PPS limits. And depending upon your protection posture or a defensive posture, you have to rely on on-premise or on-premise defenses as well, because you cannot expect ISP to measure or to stop every traffic. For that, you need to know that the existing defenses, they are traditional in nature, like IPS. IPS is only a signature-based solution, so you don't expect IPS to block your DOS traffic. For SSL as well, SSL, there are attacks which are made to test the SSL encryption mechanism, because encrypting is easy and decryption requires a lot of effort by the server, so it's 10 times slower than encryption. So the attacker would generate multiple connect sessions and doesn't complete them, but they are enough to overwhelm an SSL-based website. And then you can see that there are, you can, at the last, there it says anti-bots. So now the mechanisms are not intelligent enough to know that what is a bot and what is a human behavior. So for that, you need to know that there are certain tests where you can come up and you can see that this attack has been generated by a bot or a human. So there are 302 redirects, there are CAPTCHAs, so there are other challenges where only full stacked implementation of a browser, which is in a case of normal traffic, a browser generates traffic, not a bot. So a bot has a limited stack, HTTP stack versus a browser which is a complete stack. So if that distinction, if you can distinguish between the two, between the full stack and the half stack, you can know from bot and human traffic. So there are requests and challenges which is sent by the mitigation devices just to see if that traffic is generated by a human or a bot. So this is just a generic diagram or a conceptual diagram for a tier 1 ISP mitigation. So if you can see there's a concept called in an ISP world from a DOS mitigation, there's a phrase called a scrubbing device. So basically, scrubbing device is used to scrub all your bad traffic and gives you the clean traffic. So the scrubbing centers are placed centrally towards the core of the routers. So and those scrubbing devices get information or they get route injected or prefixes injected for bad traffic by those many collectors. The collectors are at the top or the first horizontal row you can see. So the collectors are taking net flows information as an input, and then they are building up a graph or a statistical profile. As soon as they detect that there's an attack coming in, they will automatically inject a route and advertise a prefix. So that will allow them to allow the customer traffic to be diverted to those scrubbing centers. So those traffic then gets clean, and only the clean and a good traffic is sent to the customer. And at the end, you can see there are some inline DOS devices. This is put in front of a data center or a customer-facing just for layer 7 protection. On the left, you can see a cloud signaling, the arrow or a line going on the left. This cloud signaling says that if a certain threshold attack, which is beyond the capacity or the license of the appliance, comes in, it can call on the ISP or it can call on the cloud provider to mitigate or to divert that traffic and get it clean for the customer. So as again, from an ISP perspective, these are inherent or built-in capabilities which an ISP can use to mitigate or to solve the problem of DOS. There are two approaches. One happens at the data plane layer, and other which happens on the control plane. So for the data plane, you have got ACLs, and for the control plane, there are multiple techniques. We will be discussing them further. So yeah, I think everyone is aware of the phrase ACLs. So ACLs are used for access control list. They are used for a static traffic profile where it's not that dynamic, but you know which type of traffic you are supposed not to get or to filter that traffic. So basically, ACLs allow you to do a sufficient or a adequate level of protection using the built-in ACL commands provided in any iOS or Junos or any routing OS. There are downsides of using ACLs as far as the advantages are concerned, that they are easily to configure, and they are good for traffic which doesn't changes very rapidly, and they have for traffic which has a standard deviation or from normal, like they are not that dynamic in their profile. So for those traffic, ACL works better for as far as the protection is concerned. But for the but you should know there is a considerable processing overload or overhead because applying ACLs on one router as opposed to scaling it up to 500 routers or 300 routers for the same traffic or for the same problem becomes a scalability issue. So for any router which which process for 500 megabits per second or more, those ASICs are offloaded to a line card or to a dedicated line card just for the performance sake. But even then, you cannot ensure the delay, which is shown in the 0.3 or 0.6. So if there is a correction which has to be made in the ACL, this process has to be reloaded again. And as it says, that this could take even seconds to a couple of minutes. So for a DOS attacks, that can have a major impact on the SLAs on the dollar value lost due to the non-availability of the service. So it's not a very real-time or a dynamic process. It takes time, and it takes time to define, and it's also error-prone, because on the right you can see the above ACLs is denying fragmentation attack. So you can see a small error or a small mistake, you have to go through those lines again and to correct that. So doing the root cause analysis or doing the administration of the ACLs is not very easy for the administrator. So what are the best practice for deploying ACLs? So you can think about that customers expects a clean traffic at all time. But you cannot do it with a one ACL. So you have to divide your traffic or the profile of the traffic depending upon different, you can say, layers. So the first layer, you can have the customers using the ACLs, you can drop the spoof addresses. Customers doesn't want this traffic on this ingress interfaces, so it already knows about those internal addresses like NTP, FTPs, or secure address spaces. It doesn't want it to be advertised, or doesn't want traffic to coming from the ingress interface. So there are options to limit the noise and to limit the chance and increase the chances of getting the clean traffic towards the customer. And then the second layer, you can see the infrastructure. So many would not know that their DNS, their FTP, or their NTP servers, because many people will not even test their NTP, the DNS, for amplification attack. But if there is unsolicited traffic coming out of those NTPs and FTPs, this ACL will probably help you stop those unsolicited replies coming out. So that helps you to protect your infrastructure from being used in amplification attack. Yeah, so now comes the technique which is called RTBH. So this is like, you can probably say, a self-healing mechanism, or where you can, using methodology of routing bad traffic, using the BGP and using route injections, and putting all that negative or bad traffic towards the edge, so it doesn't get towards the core or the PP routers or the autonomous systems. So the technique is called RTBH, remote trigger black holing. So there are two approaches. One is the destination based, and the other is the source based. So if you want to protect the victim, then there's a destination based methodology, and if you want to shut down the attacker, then there is a source based. So what it does, that the customer edge or the router, when it sees that it is being attacked by a certain prefix, it advertises that prefix towards the provider edge, which is a ISP end, and that prefix is further advertised among the BGP peers or the BGP routers. So it knows that anything which matches this prefix should be routed to null, or the next hop should be null. So using the basic routing principles, it is diverting the bad traffic from reaching the customers to the black hole or to the sinkhole. So black hole, sinkhole, these are all RSC-based definitions, and you can read them on those different BCPs, like BCP38 is one of them for spoofing. So the exact definitions are given in those RFPs. So if this is the victim, 172.16.61.1, and if you want to stop the, if you want to protect the victim, and you have to advertise this route to the BGPs, the following configuration has to be made. So as you would know that the customer router would inject route, which is a prefix of 172, and which a next hop set to a network which is a non-existent, which is 192.0.21. So it will do the next router which receives this advertisement or a route, it will do a recursive lookup to see what is the exact interface, or how can I take this traffic out of the device. It will refer to its FIB, forwarding information base, where all those routing tables are with their interfaces or exit interfaces information given. So it will see that this is a route null, depending upon the configuration, because the 192.168.0.21 is being routed to null, which is a bit bucket, or it's another way of telling the router that discard this traffic. It should not be routed anywhere else, but it should be silently discarded. So routing to null means to discard, or it is also called as a bit bucket or a null zero. So depending upon its GNOS or iOS, there are differences in some terminologies, but the basic concept is the same. So when you set up the next hop as 192.0.21, it automatically knows that this 192.0.21 has been routed or has been configured for a bit bucket, which is a null bucket. Doing a recursive lookups, it knows that what's the exit interface, which is it logically discards the traffic without exporting it. So to ensure that the traffic is not leaked to the other BGP peers, in the configuration you have to explicitly mention as no export. So for no export, it means that it doesn't leaks or it doesn't loop the traffic, and all the traffic is being managed by the discard router. These are some of the techniques where you can have the tag-based notification or the tag-based configuration, where multiple DOS attacks can have multiple mitigation criteria. Like you can tag one based upon spam, other based upon phishing. So this is just give you the variability option or a flexibility option in designing the BGP policy. For a community, as opposed to tag, so when you want to communicate across communities or across autonomous systems, you need to have define a community so it can be relayed across autonomous systems. So using communities, it allows you to define policies or define traffic, where not all the traffic is being discarded, but based upon the traffic profile, you can have one community addressed to that. If your DNS is down, it doesn't mean your NTP service needs to be down. So communities allows you partial availability as well. This is the same configuration. The only difference is that set local preferences used just to override the existing route, so that it doesn't divert the traffic to the original route, but uses the advertised route as a preferred route. I've already discussed the difference between tag and community. So community allows it to spread the configuration across multiple BGP routers, instead making one router responsible for all the maintaining all the configuration or all the match criteria. Other option is that a customer can also initiate. I think originally I mentioned the customer edge. So this is a customer edge, which will router which will be advertising to the provider edge router of an ISP, and it will do it within a convention with an AS number colon 666. It could be a reserve just for black holing such traffic or use in such scenarios. This is a technique where you can solve the problem of spoofing, which is probably you can say a birth defect of a internet or a protocol that inherently it is vulnerable to spoofing, and that it doesn't validate if you don't use IPsec or you don't use any other mechanisms. It is always vulnerable to spoofing. So in order to mitigate this, you need to have deploy a technique called URPF, which is unicast reverse path forwarding. So whenever a request comes or a packet comes, it checks the routing table and sees that where the traffic is being mapped or matched. If that traffic is not linked to that interface, it will discard it as a spoof request. So when it gets matched, Like if this is a DNS server, that interface X is equals to DNS or FTP, it says that it is directly attached or it's linked with this interface address. But if it says that this traffic is coming from interface not mapped in the FIB, it will discard it as a spoofing attempt. So in a loose configuration, the first was strict, and this is loose reverse path forwarding. So it doesn't care from which interface the traffic is coming as long it is present in the FIB or the routing table. So discarding it is possible when you see that there's no entry of the target address. So this has been discussed before. Yeah, you can be cautious that you need to whitelist the addresses because attacker can use or spoof Google, Amazon addresses as well. So you don't want to be put for black holing, because that will practically make you disconnect from the entire world. So the difference between the ACLs and have been discussed before, that ACLs are static in profile and they are good for traffic which rarely changes. So at the end, as I was talking about the open source option or alternative as opposed to vendor-based solutions or DDoS mitigation solutions, which are expensive, they are license-based, even some are giving you options that they only are able to mitigate certain percentage of good traffic and only a few percentage of bad traffic. So, so in order to avoid, but in some cases you are not able to avoid that choice, but to have an open source alternative is just good for the posture and good for the overall strength of your security architecture. So this is, both of these codes are available over the GitHub. The first code, the first tool, FastNetMon, it's basically a netflow collector which takes J flows, C flows, S flows, and it makes a statistical profile using its algorithm to detect DOS attacks. So so the first FastNetMon does the detection part. So it complements the entire detection paradigm. But what you need to do, that you need, based upon the detection, you need to inject or you need to advertise that traffic or towards the BGP or towards your upstream. So XBGP, which is also called a Army knife, it's basically Linux-based router, and what it does that it automatically takes the input from the FastNetMon and it automatically takes it and injects it for you to the upstream. So the whole cycle is being now automated. Instead of putting the ACLs manually to hundreds of routers, this XBGP interfaces with snorts, net flows, so it always knows where the bad traffic is coming in. So it can pump in the IP addresses and automatically injects to the border router for cancellation. So I end my presentation. If you have any questions, please let me know. Thank you.
Anybody has any question? This is a pure engineering, of course, talk, and Asad is available throughout the workshops as well. So if any of you want to connect directly in person with him, he'll be able to help you sort out some of the major stuff which you deal with in cybersecurity based on open source tools and so on and so forth, right? If you don't have final call, any question? Okay, we have a question from Atif.
Yeah, so one quick question is, the FastNetMon, is that used for DDoS mitigation, or how's that works? I mean, can you explain a little bit more about it?
Due to the, I think for the workshop, if you're available, I have mentioned the entire deployment exercise as well. But just to answer your question, it's just a detection tool because it takes the same legacy net flows protocol or IPv6, but what it does that it is able to tell a statistical profile of every traffic. So it knows that what is the normal and what is not normal for a given target application. So it can tell you by some indicators or by some possibility that this is a sync flood, this is a volumetric attack. So it does the layer 4 and volumetric visibility from a detection point of view. It doesn't mitigate automatically. It needs to be integrated or liaison with the XBGP tool to inject the routes or to do the active blocking, as to say.
Cool, thank you.
No problem.
Anybody else? Last and final call for the question on his presentation. Yes?
Thank you for the presentation. I just want to ask that you mentioned many different anti-spoofing techniques, especially URPF. So I just want to ask that which one is the most effective one? There is hope count filtering, ingress, egress, and rate-based filtering, and many others. So which one do you think is the most effective one if we come up with the one conclusion? Because there are so many techniques, so one gets confused at which one to adopt actually.
Yeah, I think the right way to answer this is you need to know the attack vector. So if the attack vector is application, these techniques will not work, especially or at the ISP level, because then again the OSA stack can only see for till layer 4, but that real attack comes in the application. So these techniques will work for ISP, but then again, what you're trying to protect against, if you want to protect the customer, then you have to use these techniques for spoofing. You have to apply this URPF and black holing because these are low, cheap options, and you don't have to integrate anything special. But then again, most of these are also reactionary. They're not predictive. They do not automatically applied. So by the time these get applied, you already have suffered a major loss. So you need to know the entire, I think, the landscape or the attack profile. So is it hybrid attack? Is it single vector attack? So probably even one technique will not help.
Okay. Yeah. Thank you.
Thank you, Asad, for a great talk. Ladies and gentlemen, lunch is served. I would request all of you to please proceed for the lunch, and we'll reconvene in another 45 minutes. We have a long agenda to cover, so please rejoin in 45 minutes.
For the next session, the presenters, please, if you can come up over here, we'd like to discuss a few things, and also the presentation needs to be copied. Presenters for the next session, if you can come up front, and so that we can compile the presentation.